Yeah, well, because I'm trying to fix the stream. Should be audio. I just muted myself. The stand is not holding at the moment, so give me 1 sec, okay? Give me one moment. Let me try to fix this. I don't know why it's not holding well. I wonder if my phone is getting too heavy. Ugh. Give me 1 sec. Hello. Yeah. Heavy phone. But it wasn't like this earlier though. Is it because it was holding just fine this morning? So finally reaching its full one sec. Being really annoying. Ugh. 1 sec. I'm having a lot of trouble right now. Huh. This is so annoying. Things are not holding up. I might just use duct tape actually. Actually I might try rubber band first. Give me 1 sec. Let me go get some rubber band. So I want us to stay here. Let's see if it works. Wow. Okay. That didn't work. Look at this. It's not working at all. I actually have a different idea. One sec. This rubber band doesn't work because the force is not in the right direction. So I'm going to do this. This is actually so frustrating. Now it's upside down. Why is it upside down? Heck. Alright, I'm gonna hold it like this, alright? For now, okay? We're just gonna have to make it work for now. I'm gonna try to fix it later, but for some reason it's stopped holding together. I want to make sure that it holds, but it's not holding. It was holding this morning. It's crazy how fragile these things are. Wow, okay. It's not working. Alright, whatever. I'm gonna try to make it work, okay? Must be something that I did or not do. Maybe my phone's just too heavy. Alright, so let's start. I'll try to make it work. No matter where we are. Okay? So today we're going to talk about surface area of a pyramid. And so surface area, so we're obviously going to calculate surface area. Okay. Pyramid. And cone. Okay? So, when you are, oh my goodness, pull this slightly higher, but it's not letting me. I have an idea. don't know what you're saying, Jeremiah. No, it's not the direction, it's that this thing doesn't clip. Like, it's falling over. Alright. I'm gonna hold it like this, okay? The best I can do now. Alright, so, maybe I can make it. It's upside down? What in the world? It looks fine on my end. Hold on. It is upside down. Oh my goodness. No, hold on. Give me. Goodness. Still good? Nope. Now it's bad again. It was good for like 1 second. Oh. Alright. Try it again. Yeah. I am so done with this. Alright, I'm gonna hold it like this. Alright, I'm gonna hold it like this. Let's see, now it's... Oh my. I'm actually so done. Anyway, so we're here. Hopefully it works now. I'm gonna just write or try to do this while holding it on one hand for now. Okay. So, I don't have rotational lock on streaming mode. So anyway, we're doing this, right? And we're doing surface area, okay? Surface area is basically the same as how we did prism and cylinder earlier, which is the base area plus the lateral area, okay? Now, when you break it up, right, then it looks like this. It will have well, in this case, we'll have 4 triangles, but it's however many triangles you have, right? And each one of these will be half base times height, half base times height, half base times height, half base times height. Okay? So the whole thing will be half S times L, which is the height, right? And then you have 4 times of it, right? Well, if you have 4 times of it, 4 times the base is the perimeter, right? So technically this is a half perimeter times length, right? That would be your lateral area. Does that make sense? So, or you can look at this as a whole rectangle and you say, oh, well, I'm only using half of this rectangle, which is half perimeter times lateral height. Okay? Now, notice one thing, that this lateral height is not the same thing as the actual height. It's the slant height, right? Because you're interested in surface area, so your surface height is what you're looking at, right? This part. That makes sense? This is the slant height. Okay? Yeah. So when you're trying to find the surface area as a whole, it's going to be lateral area plus the base, or in this case, the lateral area was 1/2 perimeter times slant height, plus the base area, however base you have. All right, so if you have a hexagon, then you have to find a hexagon. If you have like rectangle, then you have not rectangle, square, then you have to find square. Okay, that's the idea. All right, so now let's take a look at this problem. So we're gonna find the lateral area, which is all the triangles. If you're not used to this formula, it's fine to just find one triangle and then times 6. That's the same thing, okay? Just like how we did with the base area, we can do the same thing, okay? 1/2 perimeter times slant height, right? So 1/2 perimeter is going to be 10 times 6 of them, right? Because 6, so 60. Slant height is 16. You multiply them together, you will get, what's this? 480. 480. 480 inches square. All right? All right, and then after that, you can do the base. Now, the base is what kind of shape? That's going to be a hexagon, right? Regular hexagon. So if you do regular hexagon, then you have to remember how to find the base area of it. So we've done this several times already, so I'm going to give you some time to find the base area of this regular hexagon. All right, and I'll give you 2 minutes. All right, so do that real quick, and we'll verify answer once you're done. Once you're done, you can put the answer in the chat. Okay, I'll give you 2 minutes. So Jeremiah got 259.8. Everyone got similar answer as Jeremiah. I agree too. Right. 259.8 seems to be correct. Inches square, right? So you just add them up to get the surface area, which is going to be 739.81 inches square. Okay. All right. I'm trying to write around this block, so forgive my handwriting. So that's it. All right. Can you try one on the right? Try one on the right. So same method. Try one on the right. And while you do that, let me take attendance real quick since you're here. Type here if you're here. let's take a look. So you got lateral areas 1/2 perimeter times slanted height. 1/2 perimeter, right? Perimeter is 16 times 4, so that's gonna be 64 times slant height is 17, right? So that's gonna be 544 for lateral height, lateral area. And then your base is going to be 16 square, right? That's 256. Because base area is a square. And you add them up. So surface area is going to be 800. Okay, very nice. How are we doing? Are you good? Can I get a comfort level 1 to 10? So I can have an idea. Wait, 565. So when you're doing your okay, so think about it like this. If you're not sure, just do side by face by face. So think about it like I'm just trying to find the area of a triangle and then times that by 4. Okay, if you just do that, because you're finding surface area, so you're gonna find every surface. So if you do it like that, your triangle, right, T, is going to be what? Base, which is 1/2 times 16 times height, which is 17, right? Because each triangle has height of 17, right? And then you multiply that part by 4, right? Then you'll get the same thing as this equation, how it gave you, okay? And once you do that, you get 544, and then you get base, you add up, you get 800, okay? And that's the idea. All right, so no matter how you do it, you're gonna end up getting the same answer, okay? Surface area. So now let's take a look at cone. So this is cone. Let's take a look. So I want to tell you is that these are the same thing. Wait, what? We're not doing what? What are we doing? What are you saying, Jeremiah? What are you saying? All right. So remember your lateral area is what? 1/2 perimeter times length, right? The slanted height plus the base area, right? Then when you're looking at this, if you're in a cone, remember cone and pyramids are basically the same thing, right? So when you look at this, perimeter is the same thing as circumference, right? What is the circumference of a circle? Isn't that 2 pi r? So perimeter is 2 pi r then. Plus base area is a circle, so pi r squared. The 2 cancels out, so you will get this equation. Okay, pi r L plus pi r squared. Are we okay with how this equation came about? We're doing okay? Does it make sense? Alright, so if you're okay with this, alright, I'm going to flip the page, which is going to be a little hard for this one, but I'm going to do it anyway. So next part is going to be calculation. Like, we got all the formula down, right? So now we're going to try to use it to calculate. First one and the second one together. I'm going to move slightly higher. Okay, so looks like that. First of all, we're missing the slanted height, right? So we gotta find that. How do I find that slanted height? What would that be? What would that part be? How would I get this slanted height? Hypotenuse is the right triangle, so that's 8, 15. If you memorize it, it'll be 17. But if you didn't memorize, then you can do Pythagorean theorem. 8 squared plus 15 squared equals L squared. Right? Okay. Regardless, you should get 17. Okay? You should get 17. Right triangle. Okay. So if that's the case, then what I'm going to do is I'm going to calculate, right? So lateral area is 1/2. Sorry, not 1/2. Why did I put 1/2? It's pi RL, right? One sec. Oops. Not working. Hold on. Wrong set. How do I use this? I'm trying to dodge all the blocks I'm using. So pi RL, right? So pi RL, which is pi 8 times L is 17. They say leave it in pi, right? So the first one would be 136 pi. Okay? And then your base is obviously pi r squared, so pi r squared, which is 64 pi. Okay. Video. Look. Right triangle, right? So L squared equals 8 squared plus 15 squared. So L squared is 64 plus 225, which is 289. Right? And then you square root that, it will get 17. Okay? I just memorized the triples. They're called Pythagorean triples, right? They're in whole numbers, right? So then you add them up, you get what? 200 pi? Is that right? So surface area is 200 pi units in inches square. Same thing as the other surface area, you're in two-dimensional, so you are in squared inches, right? Inches, two-dimensional. Okay. How are we doing? Try the right side. Try the right side. I'm so careful not to mess this up, and then try to wait for the fix after this class. All right. So, what do we have answers? So lateral area is pi RL, right? Pi R, radius is 8. What's L? What's your slanted height? 6, 8, 10, right? Are we better with this combination? It's still the same thing. Okay, it's still the same way to calculate it, Pythagorean theorem, right? Okay, and then once you get 80 pi, you got to get the base, right? The base area. So the base is going to be pi r squared. So that's 64 pi, right? So then the surface area is to combine, add them up. 144 pi in centimeters square. that make sense? Alright, so now, before we end this, let's look at some conceptual things. So, you see this, right? This is what we've done before. Not the same exact problem, but very similar, right? They say, what if I divide both the edge length and the height, slant height, by 5? So in other words, this will be 3, this will be 2. What will happen if I divide both dimensions by 5? Remember we did something similar in similar triangles where you divide or multiply one dimension, both of the dimensions, by a number. What will happen to the surface area? Well, you remember what happened then? So for example, back in the days when we were doing triangles, right? And then we're like, okay, let's just say the triangle was 3 to 4, right? Like that. And then the other one is, let's just say 2 versus 1.5. These are similar triangles, right? How are their areas ratio? How is their ratio? It will get smaller, but I need the ratio. So how are these compared in terms of dimensions? Well, 4 to 2, 3 to 1.5, these are similar triangles of scale factor of 2 to 1, right? See that? 2 to 1. But what about their area? The area here is going to be half base times height, which is 6. Well, this one, half base times height is 1.5, which is what? 4 to 1, right? So how are they changing when you change both dimensions? Isn't the ratio have double the effect or twice the effect because you have 1/2 and then 1/2 again? So it's basically 2 squared to 1, right? Remember this? I think we mentioned this when we were doing similar triangles. Have some, do you remember? Okay, similar thing will happen because this surface area will then now be similar to the previous, right? Before divided by 5, after divided by 5. So that means the surface area will then be 1/25 of original. Or in other words, divided by 5 twice, so 5 squared, which is 25 basically. Move it up a little bit. Does that make sense? Because your original surface area is now the smaller version, but everything is smaller, right? Everything is 5 times smaller. So when you multiply by the area, it's going to be 25 times smaller. Or 1/25 of the original size. Make sense? So similar problem on the right side. They say, what happens if you multiply each dimension by 2/3? Since we already established the fact that it's going to be squared, then the surface area is going to be 2/30 squared of original. Okay? Which in this case, 2/3 squared is going to be 4/9. Okay? Does that resonate? Does that make sense? So you're doing the multiplication twice, right? Because you're doing base times height or half base times height for 2-dimensional objects. So since all the dimensions are reduced, then you'll be reduced twice when you're doing area. Okay? Comfort level 1 to 10 for this particular piece. Ratio. 10 makes a lot of sense. One means I have no idea what you're saying. Alright, last piece is the challenge piece. Although it says challenge, it's not really that challenging. It's just alright. Basically, it comes down to the idea of composite figures, but with cones. So how are we doing with this? So first of all, we have established the fact last week that we cannot just calculate each one of them and then add them up, because the base is covered now, right? You see? So only on the surface we're looking at. So this part doesn't count. Okay, does not count. This part. So then the problem becomes really simple, right? We only have then what? Lateral 1, lateral 2, right? We only do 2 lateral areas. Does that make sense? Because the base is no longer there, right? You cover it. So the problem becomes simple. 2 pi RL. Which is 2 pi r is 2, L is 6. Very simple, 24 pi feet square. Alright, squared feet. Make sense? So homework 11.7. This is online, big ideas. Due Sunday, May 31st. Make sure you do the homework. We are running out of days. I think next week is our last day. Originally I was going to give you a final, but I haven't covered 11.8. I counted 1 week less. So next week we'll cover 11.8, and we'll have some final words, and we'll close it up, basically. Okay? We're going to talk about spheres, Cynthia. Spheres. There's one more piece, right? So, since we're doing pass, no pass, the final is sort of, it's mostly participation grade anyway. If you notice that your current grade with the last test, I basically put it as participation, right? So, same thing would happen with the final, so might as well just do 11.8 so you can learn something at last, right? Before we part ways, right? Okay, any other logistic questions before we go? Let me just make sure that you guys get this, and let me try to fix this thing. We're comfortable with this? Maybe next week's gonna be the last time we ever see each other. So we're good? ASMR. You guys into that kind of thing? Do you guys sleep while listening to ASMR? Like trying to fall asleep? Like some of them are really intense. Like, that's fine. I got you, Glenn. Well, I need to go fix this stand, okay? If nothing else, then you're free to go. Olivia, you would say that. Goodbye.